Hi everyone, welcome back to our channel. Today, we are diving into the fascinating world of cognitive radio systems. In this video, we'll be covering the basics of cognitive radio engines, exploring their concept diagrams, and understanding the three types of parameters they use. Contents. Introduction. Concept diagram of a cognitive radio engine. Three types of parameters employed by a cognitive radio system. Wireless networking device configuration and networking environmental parameters. Wireless networking target experiences. Conclusion. The concept of cognitive radio is a powerful methodology for performing communications where each radio within the network has the capability to sense its environment, adapt its operating behavior, and learn about new situations on the fly as they are encountered. As a result of cognitive radio's ability to sense, adapt, and learn, it requires the communication system it is operating on to be highly versatile. Consequently, SDR technology is very well suited for implementing cognitive radio-based communication systems. If we study Figure 11.2 more closely, we can see that the cognitive radio engine consists of several inputs: sensed environment, expected performance metrics, available radio configurations, an output, radio configuration to be implemented, and a feedback loop. At the heart of the cognitive radio engine is the decision-making process, which determines the best possible radio configuration to be implemented based on past experiences, available radio configurations, sensed environmental parameters, and desired performance metrics. A cognitive radio engine, continuing. The decision-making process is often implemented using machine learning, of which there is a plethora of choices to select. To understand the design considerations for a cognitive radio engine, let us look at each of these elements more closely. Machine learning techniques have been extensively studied to either partially or entirely automate the re-configuration process. However, the solutions produced by these techniques often require some knowledge of the wireless device and the target networking behavior, example, high data rates, high error robustness, and low network latency. Nevertheless, machine learning techniques are well suited to handle scenarios possessing a very large device configuration solution space. One major issue affecting cognitive radio systems is the accuracy of their decisions, which are based on the quality and quantity of input information to the cognitive radio engine. Thus, with more information available to the system, this enables the cognitive radio engine to make better decisions such that it achieves the desired user experience more precisely. Referring back to Figure 11.2, three types of parameters employed by a cognitive radio system exist. 1. Device configurations. 2. Environmental parameters. 3. Target networking experience. Three types of parameters employed by a cognitive radio system. 1. Device configurations, a collection of parameters that can be altered to change the current operating state of the device. Note that several potential configurations may not be possible to implement, and are thus disallowed by the adaptation algorithm. 2. Environmental parameters. These parameters represent the information about the current status of the device as well as its sensed wireless environment using external sensors. 3. Target networking experience. These metrics approximately describe the average human user's experience when operating the wireless networking device. The goal of any cognitive radio is to achieve the best possible value for a given metric. Since all applications operate in different environments and poses different requires, a solution produced by the cognitive radio engine for one application that achieves superior performance might yield unacceptable performance when that same solution is applied to a different application. The definition of an optimal decision is a combination of device configuration and environmental parameters that achieve the target networking experience better than any other combination available. Defining a proper list of parameters constituting a device configuration to be employed by a cognitive radio system is of prime importance. Wireless networking device configuration and networking environmental parameters. A well-constructed list consists of common wireless parameters that each poses a large impact on the target networking behavior. Table 11.1 shows a list of 9 transmission parameters commonly used in wireless networking devices. In making decisions, These variables along with the target networking experience are used as inputs to the algorithm. Table 11.2 shows a list of 6 environmental parameters that can affect the operational state of a cognitive radio device. The purpose of a machine learning-based cognitive radio system is to autonomously improve the wireless networking experience for the human operator. However, improving this experience can mean several different things. Much research is focused on improving the accommodation of many wireless users within the same network. Wireless networking target experiences. Other important aspects include providing error-free communications, high data rates, limiting interference between users, and even the actual power consumption of the wireless networking device, which is extremely important in mobile applications. As shown in Table 11.3, we have defined 5 common target networking experiences that guide the cognitive radio to a specific optimal solution for the cognitive radio system. The target experiences presented in Table 11.2 represent the means for guiding the state of the cognitive radio-based wireless system. The cognitive radio makes use of these experiences through relationships that describe how modifying the device parameters achieve these objectives. To facilitate the decision-making process, each target networking experience must be represented by a mathematical relationship that relates a device configuration and environmental parameters to a scalar value that describes how well this set achieves the specific goal. These functions will provide a way for the cognitive radio to rank combinations of configurations and environmental parameters, ultimately leading to a final decision. Note that it is possible to specify several target networking experiences simultaneously, with the final score being represented by a numerical value. In this case, the individual scores of the target experiences are weighted according to their importance in the specific application and summed together, forming the final overall score. In conclusion, this presentation has explored the fundamental aspects of cognitive radio systems, including their core concepts and the essential parameters they employ. We have discussed the configuration, environmental parameters and target networking experiences of wireless networking devices. As cognitive radio technology continues to evolve, its application will increasingly enhance the efficiency and reliability of wireless communications, paving the way for more dynamic and resilient network systems.